And let me start this session with 2 questions for every one of you. Who of you has used an AI-enabled tool within the last week? Okay, I would say roughly 60% of hands were raised. Now the second question. Who of you has used an AI-enabled tool within the last week for your production or engineering system? Okay, way fewer hands, maybe 30%. What does this tell us? It tells us we have a huge potential to use the tool of AI within the production system to make our lives easier. But AI and all the hype and tools around AI is rapidly changing. And it's hard sometimes to keep track what is now important, where we're standing, and what is possible. For this reason, I have an amazing co-speaker with me, Simon Hirländer.
Thanks a lot, Lukas. So it's almost exactly 2 years ago that I was exactly here on this stage giving a talk which was called AI is what we make it. And I think that this is the way to go. And so I'm really proud to be here with all of you to go on this journey. And let's start. So AI is everywhere nowadays. It's in our everyday life. We have it on our phones. We have speech recognition. We have recommendations which are targeted to listen to our favorite music. We have voice assistants at home which control parts of our household. In creativity and culture, AI can generate impressive images, can generate videos, can generate texts, blogs for us even. It can translate several languages in real time. But also in science, we have huge discoveries with AI nowadays. Last year, the Nobel Prize was awarded to the drug discovery through AI in medicine, which saves many, many lives in the future. But also in astrophysics, we discover new objects on the sky with AI. Or in climate modeling, we have tools which can predict the weather faster and better than ever before, which is very important. But last but not least, work and industry. We have predictive maintenance tools which predict when a machine will fail before it actually fails. In process automation, we have robot arms which are guided by visual systems. We have decision support systems which guide us in decision-making in logistics or supply chain optimization. But this was not always the case. So I traveled with you now to CERN, which was mentioned by Lukas already, where we study fundamental questions about the universe. We try to understand how came the universe into existence, what holds things together. And in order to do so, we built big machines. We have many experiments and many machines with a complex to answer these questions. This is how such a machine looks like. This is the low-energy ion ring at CERN I was in charge of for a while. And this is how it looks like when you control such a machine. You have many screens. You have to take care of many things at once. And this is done by humans, by human operators. And I thought at that time, there must be an easier way. So I started to introduce very simple automatic optimization techniques to improve this. And slowly, we implemented more and more AI and machine learning tools, which led to a more reliable and better performance. In some cases, even the best performance ever seen. Much easier than ever before. And this is ongoing. It's just the start. And we have more and more agile systems. We have a plug-and-play system nowadays where we look at our problem, we decide what tool do we use, we bring it together, and then we go. But let's have a look where we are generally in AI. We go 30 years back now. There was the game of chess won by a computer program against Garry Kasparov, a chess genius. This was in 1997 by Deep Blue. And this was AI, but not the AI we use nowadays. It was more rule-based, as we call it. I will explain in a while. And then, around 20 years later, there was another great breakthrough, an unexpected breakthrough, because the game of Go was won by a computer against one of the best Go players who ever lived. This is interesting because Go is much more complex than chess. It took us 20 years to have a system which is better than a human. And this was like an earthquake to Asia, because in Asia this is a holy game. And they decided to invest into AI. This led to strategies. Also in research, things got a new movement. We saw that we can do better. And then there was AI to the masses effect. In 2022, ChatGPT was released. I think since then everybody is aware of what is AI, what AI is capable of, in principle. So this changed the world forever. It was the most successful application ever released in history. Within 2 months, they had 100 million users. If you go back 10 years, WhatsApp needed 2 years to get the same amount of users. So this shows that things are increasing in speed. Things are faster and faster. So let's jump to 2025. This is one example. There are many things which happened in between. This is the example that a computer program was able to score gold on the International Mathematical Olympiad. This is insofar interesting because this is a set of very hard mathematical questions selected by a committee who take care that this is not easy to find online, if it is even online available. So it was not accessible to the programs ever before. And what happens now? What happens next? I think AI can now reason better than ever before. It learns, reasons, and starts to act in the real world. This is where we are now, and this is what starts now. Let's have a look how AI learns. Usually, we have some ideas about the world, we develop some rules, we have some data, and then we program this into the computer. Let's say we want to regulate the temperature of a building. Then we would say, if the temperature surpasses a specific threshold, then do something. So this is then the answer, do something, and this is decided by us. AI works differently, modern AI. We have data. Let's say we observe somebody regulating the temperature. We know when somebody turns on or off the heating. So we have the set of observation and the set of what to do. And then we put this in to a so-called machine learning algorithm, which is the modern form of AI. And this algorithm then finds out the rules on its own. This is what machine learning algorithms do. So it's so important that we have consistent data to discover good rules. We need a good data management to have good AI. As I said, machine learning is the main part of modern AI. It has three main pillars it relies on. One is that we have data and we try to find patterns without any strong influence on our side, hidden patterns. The other one is the one I explained, where we have the answers, we have the data, and the algorithm tries to find out the rules. And there's another one, which we only barely give some information, and the algorithm finds via trial and error how to derive good strategies. So everyday AI, as we all experience it nowadays, was trained on the data which we find on the internet. We have labeled images, we have a lot of text. And these tools imitate the patterns it found online. Nothing more. And this leads to the following. We are impressed by these answers. We can prompt some information and we get impressive images, for example. But this could have been done by us, in principle. And this other AI version is capable of discovering new strategies we did not think of. This is an example where only a few years ago we found new ways to perform matrix multiplications on computers much faster than we thought of ever before. The computer found new ways, new algorithms on its own. And the matrix multiplication is just a set of simple multiplying numbers with each other. So one could think, okay, we know how to do this. But this was not the case. And this is very important because it's on every device. So this is an operation which is everywhere. It just speeds up a lot things. But it goes even beyond. So I think what is really interesting is that we start thinking in static models and try to go towards dynamic learning systems who learn on the fly. Let's say this is our world, this is the observation. We model this world, and then usually we start to decide. We derive a strategy, but the world changes, either through our decisions or on its own. So we want to close this loop. We want to have a feedback loop, that the model is aware of these changes. New algorithms can handle long-term consequences. This is something really promising, and this is what I think is the future, or will become the future. Let's come back to industry. We have many challenges in industry. For example, high costs. High costs caused by maintenance, by downtimes, by inefficiencies, by increasing energy prices, by supply chain challenges. Sometimes we face the problem of energy peaks, which is not only costly, but also there's an impact on the environment. And last but not least, we face rigid systems. We build up systems which work, which are maybe not easily transferable to new situations. They are not easily adaptable. They are rigid. So what do we demand? What do we need when we want to bring these very nice ideas of AI into our environment? We need to think about the foundation and the integration. So we need to think differently. It's not just a standard software. It's something which needs a reliable foundation, which needs something which can be integrated on top of existing things. It needs access to robust data management. We need domain experts who tell us exactly what is important and how to do things. Trust matters. These systems operate on critical aspects. So we need systems which are transparent, which we understand, which we might be able to explain in order to trust these systems. We don't want black boxes. And we have to do the integration with care. We have to be sure that we don't throw away legacy systems. We don't interrupt operation. We keep on going and just slowly start to incorporate these new paradigms of thinking. There's something new upcoming, which refers to the last point I showed in the history, that new algorithms start to interact with the world. They start to act. This is what we call AI agents. AI agents are programs who observe and act. And they can handle really complex tasks. They are maybe even able to build and orchestrate complete workflows. And this we see now, and this comes more and more. So break it down. An agent or agents observe sensory data. Then this data is analyzed, optimized, and then the agent takes actions. This can be done even in real time. But this has to be done with great care. We have to know exactly what these agents can do and what these agents should not do. We need something like a USB-C for AI in this case. We need good standards that this works well. So if I would dream out of my experience I had so far, what should a software platform deliver? I think these are 8 points which are very important. It should connect everything together. The sensory data to the machine to the IT. It should be cloud native. We heard this before. It should run everywhere. We should stay independent. We should not have this vendor lock-in problem. It should work across all platforms. We want to have the guarantee that everything is compatible, that we can take always old versions and run it right away in our new system. We want to empower engineers, that engineers can focus on the problem, not on the software environment. We want to speak open standards like this USB-C for AI. And we want to have a consistent data management that AI really can shine. And last but not least, This should break boundaries between departments, between systems. If everything is connected, you can make really good decisions within your system. So now, Lukas, how does Zenon fit into all of this?
Yes, very good question, Simon, and thank you. And if I read, and we all together read those pillars we need in an ideal world in the future for a platform, I feel very empowered with Zenon, because I think most of those topics we cover are covering within the next years. And let me just jump right into it. Let's start with the base layer, Zenon as a data feed. We heard today already and yesterday about the vast amount of connectivity we provide on open standards, legacy and new ones, from various fields, brown fields, green fields, you name it, and we all can pre-process it in a homogeneous manner and store it in a centralized data storage. You have it then in one platform, all your data from various kinds of fields, various kinds of sensors. But only storing the data is not enough, because we have to make use of it. So that's the reason Zenon is an open platform. We have a vast amount of different connectivity options to connect to for your specific systems, like you can use Python, you can use GraphQL, or simply a REST API, just to retrieve the data and make use of it. You all entered today's event through the main hall. And in the main hall, we have an exhibition where we connected a GPT instance to exactly the REST API, and to just prompt it with some basic information you can think of for retrieving some information of your wind turbines we have connected as demo project. And these are the two main pillars. The integration and interfaces we provide for cloud-hosted or server-hosted instances, because we need that much computing power for GPT, etc. And the most important part, the feedback. Because as Simon mentioned, we need the feedback and the constant evolution to make better decisions, not only now, but also in the future. But there is more. With this year, we launched also a Python engine within Zenon Logic, within the containerized PLC. And I'm very excited for it, because it's cloud native. That means it can run in your server rack, but you can choose and just drag and drop it to your local industrial PC. It's just a plug and play. And as within your PLC coding environment, you can make libraries and provide some sort of plug and play, just use this function block for your code. And, which I'm even more excited, is the project we did together with Simon regarding a model for load management to try to minimize the average consumption for companies to have the lowest energy price possible. But Simon, please tell us more about it, how we solved it.
Thanks a lot. So it's a very exciting project, and it showed how easy we can use modern AI tools to incorporate them now with Zenon Logic. So the idea was already given by Lukas. We have a blend, we have data, we have a model, and we want to act. So we have here shown the control algorithm and the blend, and the control algorithm observes the situation, and then, this is called an agent control algorithm, and then it controls something. It improves the situation. This changes the world, and we observe new things, and we act again. That's good. That's a closed loop, and it can perform well. Nevertheless, on top of this, the agent itself starts to understand how the system works. It starts to see the patterns which are underlying the patterns of the blend of the customer, and starts to think about the consequences in the world. This is extremely interesting. Here's a short video to just illustrate the difference if you do a static control, even done with AI, versus something which learns on the way. So there's this power consumption on the y-axis, and we have a limit we should not surpass. Because if we surpass it, we have to pay. We have to pay for the electricity that the company provides this electricity. So the red line is a standard approach with AI. You see it hits this line several times. It does not even learn that it hits this line. While when you're using something more adaptive, you learn to use the energy much, much more efficient over time, and you don't violate ever these constraints. So this is very powerful, a very powerful concept.
Yes.
So I hand over to you.
Yes. Thank you, Simon. It's always amazing to hear the outcome of this project. And this runs in Python within Zenon logic on the edge. And amazing what is possible. But let me just cover one more topic which we did not cover so far. This is all runtime environment on your systems. But most of you are probably thinking, all good if we can optimize the runtime, optimize our processes. But what about engineering? I want to have a fast engineering experience. And for this, there's for one, the engineering assistant. It's an agentic AI tool for prompting questions about the Zenon software platform. And for the future, also an agent where you can generate your project content just by typing, I want to have my substation ready and up and running. At least in my head. But engineering assistant is already available, and you can check it out and ask it everything in any question. It will answer everything. If not, it will guide you through the right people to contact. And with the concept of cloud native, to have the same computing stack as IT environments, which using AI already, we can have a world where you can use this cloud native technology to spin up multiple PCs, to have a common interface like Model Context Protocol, describing to the AI what is possible with the platform, and then to just generate it. But that's the vision, that's the future. And this is then the whole picture, what is possible, how you could interact with within the Zenon software platform with a strong foundation of your data, retrieving it, homogenizing it, and then make use of it. Just to recap one more with the same slide as yesterday, because SDA, as we heard, is just the enabler. Zenon is the information layer, built on an infrastructure layer compatible with cloud native, and then enables agentic AI and engineering for the future. But Simon, which impression does the Zenon software platform, after you had the take on it, leaves with you?
Well, my head is spinning. So many ideas. We can do so many things. If everything is really connected and we have the data, then we can make much better decisions than ever before. So you could, for example, think that you find a problem down the road in your production line very easy, or at least there is an easier way now to do so.
Yeah.
Or think about the project I just presented, where we have a system which slowly gets an idea about the system itself. It is creating a digital twin on the fly where you can start to probe different actions. So endless possibilities, I would say.
Yeah. Glad to hear from the expert this take. And yeah, with Zenon, you're ready to leverage AI, so let's leverage it together. Thank you.